Okay, so we are learning about the law of sines. Sine, cosine, tangent applied to right triangles only. The law of sines applies to non-right triangles as well as right triangles. Okay, but mostly for a right triangle you apply sine, cosine, or tangent. For non-right triangles you can apply the law of sines. Tomorrow we'll learn, actually not tomorrow, but Monday we'll learn about the law of cosine. So, this is the law of sines. What you have here is you have three different ratios. Sine of angle A over side A will be equal to sine of angle B over side B will be equal to sine of angle C over side C. When you use the law of sines, you choose 2 out of 3 of these ratios to set up a proportion that you can cross multiply and solve. Remember, the capital letters with the sign, those are all angles, and the lowercase letters are the sides. You also have to remember that angle A and side A are across the triangle from each other. Angle B and side B are across the triangle from each other. Angle C and side C are across the triangle. So this is what I'm talking about. If that's angle A, that's angle B, that's angle C. This is side A, this is side B, and this is side C. They're always across the triangle from each other. So you have to be able to plug into the law of sines correctly, obviously, to use it. Alright, so in this example, we have a triangle given to us, triangle ABC. We know angle A is 79 degrees. We know angle B is 52 degrees. We know side B is 28 centimeters. And we know that is side B because it's across from angle B. And we are being asked to find side A, which they have marked with the variable W. So we're going to find W. So if we take a look at the law of sines, we have sine of angle A over side A is equal to the sine of angle B over side B is equal to the sine of angle C over side C. And I told you we only choose 2 out of 3 of these. Well, we know angle A is 79. We are trying to find side A. So we definitely need to use that. And we know angle B and we know side B, so we're definitely going to use that. So we set up our proportion by plugging in what we know. We know angle A, so that becomes sine of 79 degrees. We don't know side A, that's what we're being asked to find, so we put W in there. We know angle B is 52, so that becomes the sine of 52 degrees. And we know side B is 28, so we plug in 28. Now, we have a good old proportion, and we always cross multiply to solve proportions. So we're going to cross multiply here. So we have W times the sine of 52. So then we're going to cross multiply 28 to sine 79 degrees. And notice that I'm putting the side lengths in front of the sines. To solve for W, we need to get W by itself, so we can divide both sides by the sine of 52 degrees. These cancel out, leave you with W equals, and I'm going to throw all of that into my calculator. So W comes out to be 35, in this case, centimeters. Okay, one more example. Here we're being asked to find angle A. That's where the question mark is, so that's what we're trying to find. So if we're trying to find angle A, we obviously have to have the part of sine that has angle A in it. So we have the sine of angle A over side A, and if you look at the triangle, We know angle C and we know side C. So we're going to use that part too. Sine of angle C over side C. So let's plug in what we know. We don't know angle A, that's what we're trying to find. Side A, opposite the triangle from angle A, is 36. Angle C is 42 degrees. And side C, again, which is opposite angle C, is 29. Again, we solve a proportion by cross multiplying, but there's no need to do this cross multiplication because we're trying to find angle A. We just want to get sine A by itself. So we're only going to do the 36 times the sine of 42 cross multiplying. So that'll get rid of the 36 in the denominator and leave me with sine A equals 36 sine of 42 over 29. Now remember, when we're trying to find an angle, we have to use the inverse trig function. So really what we have to do to get angle A by itself here is we're taking the inverse sine of both sides of this equation. Now the inverse sine undoes the sine, and that's what gets me my angle by itself. And now all of this on the right side, I can plug into my calculator. So angle A, 56 degrees.